So, tying parallel circuits together with series circuits. I've got this example up here. I've got a 2 ohm and a 4 ohm that are in parallel, and then I have a 6 ohm that's in series. I have a 12 volt over here, but that's not really all that important right now. When we calculate current, it would be certainly important. What I want to do is to calculate the total resistance. So when we do this over and over, I want to calculate that current. We need the total resistance. So how would I go about doing that? Well, in the case of any circuit, the first step you should do is try to eliminate the parallels. If I could remove the 2 and the 4 and put an equivalent resistor, one resistor that would have the exact same resistance as the total resistance across that parallel circuit. It would be the simplest way to do this problem. So the first thing I want to do is eliminate that parallel circuit. So what's the total resistance in that case? Well, when I deal with parallels, 1 over RT is equal to, in this case, 2 ohms, 1 over 2 ohms plus 1 over 4 ohms. So I have 1 over RT is equal to 2 over 4 ohms plus 1 over 4 ohms. So I get my total resistance to be 4/3 of an ohm. Okay, 1 1/3 of an ohm. Cool? No, that kind of looks like a 5. Still kind of looks like a 5. But that's 3 ohms. So that's the solution for the parallel circuit. So what I could do is I literally could run a resistor through here that had a resistance of 1 1/3 ohm. So I could do that, make my problem a lot simpler. I already can leave it alone and know that the equivalent resistance for the series of 2 and 4 ohms is 4 1/3 ohm. Okay? Sorry, my brain's fried. Now what do I do? Well, I want to add that to my 6 ohms. So I have 4/3 ohms, and then I have a 6 ohms. Now when we're dealing with things in series, we simply add them straight across, plus 6 ohms. Okay? So it was 1 1/3 plus 6. So I'm looking at 7 1/3 ohms across the entire circuit. Through the entire circuit, there's 7 1/3 ohm. Okay? Now, if you look at that, well, 7 1/3, I have my voltage, I have my total resistance, I can quickly find my total current. Go back in the previous movies if you need help on that. And then at that point, I have a parallel here with current flowing through it. With a potential difference. Calculate the current across there. I'm good to go. I mean, this is the tricky part, is being able to calculate the total resistance. Once I've calculated the total resistance, I can get the total current. Once I've calculated the total current, I can find the voltage across this point, calculate the current through here, current through there. I'm done. I wanted to look at power. I've got power. I've got total power. Once I have the total current, I have the total power produced. Once I have the total power produced, find the voltage across those points, find power loss here, power loss here, power loss here. Done. Okay. So this really is the tricky part, but it's the important part. It's the part you need to start with. Finding that total resistance so I can find the total current. Okay? Cool.